So a flask we're given has a can hold, let's see here, 158 grams of water at 4 degrees Celsius. Well, they're giving us that um, temperature because at 4 degrees Celsius, all right, so at 4 degrees Celsius, let me go this way, 1 gram of water takes a volume of 1 milliliter of water, which is the same thing as 1 cubic centimeter of water. Okay, this is why we also say that the density, that's rho, or you can call it D if you want. You can write it D if you want. The density of water is 1 grams per cubic centimeter at 4 degrees Celsius. So that's just something we just want to put in our memory bank. Okay, so let's. What I'm saying is we can convert that. Let's use that information, and this flask. Let's say this is your flask, and it can hold. No, we don't need. Okay, let's keep 158 grams of water. That means the volume is 158 milliliters. That's the volume, and the flask is not going to grow bigger or smaller. It's going to stay the same. So the volume is going to be 158, no matter what you put in. In this case, we're going to put ethanol in there. And so the mass of ethanol is given to us, mass of ethanol equals 127 grams. We know the volume of whatever it is going to be 158 milliliters because we figured that if it can hold, we just figured it out earlier right here. So we have the grams of methanol and the volume of methanol and anything that we put in that flask. We can get the density. So that's what the question is asking for. So the density of ethanol is 127 grams over 158 milliliters. You gotta punch those numbers in. Don't leave your answer like that. 127 divided by 158, 0.803. Peek at the next number. That's going to round your last digit up because we need 3 significant figures, right? Because that's how many sig figs we were given. When you multiply or divide, your calculated answer has the same number of sig figs as your measurement with the fewest sig figs. Right? Add the unit there, grams per milliliter, or you can say grams per cubic centimeter. That's the same deal.